We're starting with a mid-level tint, and we're going to ramp the brightness up and down and look at the shape of the PWM and the duty cycle. That's full brightness, dimming down, minimum brightness. See the PWM frequency change? Now we're coming back up to full brightness, ramping down, ramping back up, ramping down, ramping back up, and now we're going to ramp down to a minimum, and you see how the PWM frequency changes. Up again. Now we're going to run all cool LEDs and ramp the brightness up and down. You'll see how the PWM changes from almost 16 kilohertz down to 3.9 kilohertz. It starts with a DC offset, turns into a square wave, ramp it back up, DC offset, ramping back down to 3.9K, ramp it back up, and we finish with a DC offset. Let's do it one more time. Ramping down, ramping up, ramping down, ramping all the way down. Whoops, not quite. There we go. Down to the bottom and back up to full brightness once again with a DC offset. Now we're going to start with a mid-level brightness and ramp the tint up and down. It starts with about a 50% square wave, 50% duty cycle. See the unique waveform as it changes, and it's symmetric each side of the tint ramp, going from blues to warm and back again. And once again, changes from a square wave into that unique waveform. Now we're going to ramp both the tint and the brightness, starting with a dim warm to a bright cool. And I've changed the time scale on the oscope so we can zoom in on the waveform better. Warm and low, up to full on cool. See, it's not quite a DC offset. There's still some interaction between the two LEDs. Cool, warm and dim, cool and bright, back down to warm, back up to partially, and then back down